Hey, today I thought I would do another integral, and we have one from MIT 2020, problem number 3. We have the integral from e to e to the e, natural log x, natural log x over x dx. Okay, one thing I noticed about MIT is they do a good job of confusing us with a lot of natural logs and e's, especially e to the e here is a bound. Now for my first step, what I want to do is a u substitution. This is kind of optional because it doesn't really do anything. I'm just doing this u substitution to kind of clean it up and make this easier to look at. So you could easily skip this step. But I'm going to make my u natural log of x, and then getting our derivative du is just going to be 1x dx, which we notice we have right here. You notice we have our 1x right here with dx, so that's going to be nice. So let's make the substitution, updating our bounds. When we plug in e to the e in for x here, that's just going to be natural log e to the e. Picture pulling that out front, and natural log of e is 1, so we're just going to have for this upper bound e. Plugging e in for x, we're going to have just 1, just like we said over here. Then we'll just make the full substitution, so this natural log is going to be a u. Then we're going to have natural log of u. Not worried about this x, because this 1 over x dx, this whole thing is just going to be a du. And now you notice this is a little bit easier to look at. We can do this using integration by parts. So I'm going to do this real quick with the DI method or tabular integration. So we'll create two columns. We'll differentiate our natural log of u, and we'll integrate u. So integrating that, we're just going to have u squared over 2. Derivative of natural log of u is just going to be 1 over u. The diagonal will be part of our answer. So we're going to have u squared over 2, natural log of u, and then this next part's an integral. We'll take our minus sign, but 1u is going to cancel with u squared over 2, and we're just going to, I'll pull a half out front, okay, and then we're going to have dividing u into u squared, we're just going to have the integral of u. Then next we just need to integrate u, so integral of u is just going to be u squared over 2, and we just need to evaluate this all from 1 to e. So we'll just plug this all in, so we're going to have e in for the u squared, so we're going to have an e squared over 2 natural log of e minus half times half is 1/4. 1/4. We'll have another e squared. Next we'll plug in our 1, so 1 in for u squared, we're going to have 1 over 2 natural log of 1 minus, this is a 4th again, and then we're going to have a 1 in for u squared, it's just going to be a 1. So natural log of e is going to be 1, so we're not worried about that. Natural log of 1 is 0, so that goes away. Okay, now with what we have left, let's just finish this off. So minus here, minus and minus is a plus. We can look at this half e squared as, we'll write it as just 2 e squared over 4 minus 1 e squared over 4 plus 1/4. And then this is actually just going to be e squared over 4 plus 1 over 4. And I'll just factor out a 1/4. So we have left for our final answer 1/4 e squared plus 1. That's it. It was MIT 2020 problem 3. Thanks for watching. Please like and subscribe. Have a good day.